Hello, I am Professor J. Digavli, Kekewak College of Agricultural Engineering and Technology, Nasik. Today we will discuss about the topic of essential plant nutrients, part 2. Function and deficiency symptoms of nutrients. Calcium content. It is constituent of cell wall. Then it helps to maintain membrane permeability and stability. Then next one, it retards abscission and senescence of leaves. It important for growth of meristem and functioning of root tips. It is neutralize the charge on acidic molecules of phosphoric acid and other organic acid, that is citric acid, malic acid, oxalic acid, which are injurious to plant growth. Then plays an important role in germination and growth of pollens. It increases nodulation in legumes. It is required for cell division and cell elongation. Then deficiency symptoms. Deficiency symptoms first appear on younger leaves. Its deficiency is manifested by failure of terminal buds and apical root to develop. Thus, the growth of plant ceases. Then, deficiency of calcium leads to tip burn of cabbage and cauliflower. Then, black heart of celery. Then, blossom end rot of tomato and pear. Bitter pit of apple. Then, blossom end rot of tomato shows in this first picture, and bitter pit of apple deficiency symptoms shows in second picture. Okay. Then magnesium, it is key element of chlorophyll production, improves utilization and mobility of phosphorus, activator and component of many plant enzymes. Then it is directly related to grass tetany. Then it increases iron utilization in plant. Then influence earliness and uniformity of maturity. It required for the reaction involving phosphate transfer from ATP. Then deficiency symptoms. It may occur on acid soils, sandy soils, or soil with high K levels. Then deficiency symptoms first appear on older leaves. Then deficiency symptoms manifest themselves in terms of intervenial chlorosis. Then grass tetany is a nutritional disorder common in cattle grazing on magnesium deficient pasture. Then cattle consume low magnesium forage may suffer from hypomagnesemia, which is abnormally low level blood magnesium. Then sand drawn disease in tobacco. This picture shows that in leaf first, this is the intervenial bidding, then intervenial chlorosis. Okay. Then sulfur, it required sulfur containing amino acid, that is cysteine, then cysteine, then methionine. Sulfur is required for the synthesis of volatile compounds. It is responsible for characteristic taste and smell in plants of mustard and onions. Pungency in onion, it is due to allyl propyl disulfide. Then pungency in mustard oil due to allyl isocyanates. Okay. Then it improves the oil quality of oilseed crops. It improves the baking quality in cereals grain necessary in chlorophyll formation. Then deficiency symptom first appear on younger growth as it is immobile in plants, then fading of normal green color in young leaves. It is followed by chlorosis is the most common deficiency symptoms. Then older leaves become puckered with inward raised areas between the veins. Then in brassicas, which are most susceptible to sulfur deficiency, The leaves are narrow, show cupping and arresting the growing points. Then this plant shows different deficiency symptoms. Deficiency symptoms of nitrogen, phosphorus and potassium. First plant is the healthy plant, then second plant is the phosphate deficient, then third plant is the potassium deficient, and fourth plant shows that nitrogen deficient. Okay, then micronutrients. The micronutrients are boron, chlorine, copper, iron, manganese, molybdenum, zinc, and nickel. These plant food elements are used in very small amounts, but they are just as important to plant development and profitable crop production as the major nutrients. Especially, they work behind the scene as activator of many plant functions. Then boron. Boron is the only non-metal element among the micronutrients. It is essential of germination of pollen grains and growth of pollen tubes. It is necessary for sugar translocation. Then essential for seed and cell wall formation. It promotes the maturity. Then taste in cauliflower is due to presence of boron. Then deficiency symptoms. Browning, browning of cauliflower, then top sickness of tobacco, then fruit cracking in tomato, then hard fruit of citrus, hen and chicken disease of grapes, then then hollow stems of cauliflower. Then chlorine content. It plays important role in osmoregulation. Then chlorine in abundance suppress the plant disease. It regulates the turgor potential of leaves. It is cofactor in magnesium containing water splitting enzyme photosystem second. Then copper content. It is component of plastocyanin. Then it is catalyze several plant processes, that is desaturation and hydrolysis of fatty acid. It is essential for photosynthesis. It enhances the fertility of male flowers. It imparts disease resistance to plant. It improves flavor of fruits and vegetables. Then deficiency symptoms. It is the sterility of male flower, then chlorosis of younger shoot tissues, then necrosis and leaf distortion are the characteristic deficiency symptoms. Then it is reclamation disease of citrus, dieback of citrus, then gummosis and xanthomania disease of citrus. Then iron. It promotes synthesis of chlorophyll. It acts as an oxygen carrier, that is lega hemoglobin reaction involving cell division and growth. It acts as an enzyme indicator. Then iron deficiency symptoms. It is without iron deficiency with Fe deficiency. This plant shows. Then deficiency symptoms. It completes intervenial chlorosis, then scorching of leaves margin, then growth of plant is poor, dry matter accumulation is adversely affected. Then manganese function as a part of certain enzyme system. It aids in chlorophyll synthesis. It increases the availability of P and C. Then it required for maintenance of chloroplast structure. The deficiency symptoms more severe on middle leaves than on younger leaves. On dicot plant, intervenial chlorosis. On monocot, the plant greenish gray spot and strips. On basal leaves, deficiency on magnesium leads to pahala blight of sugarcane, gray specks of oat, marsh spot of peas, speckled yellow of sugar beet. Then toxicity of magnesium leads to crinkle leaf of cotton. Then molybdenum, it required to form the enzyme nitrate reductase, which reduces nitrates to ammonium in plant. It aids in the formation of legumes nodules needed to convert inorganic phosphate to organic forms in the plant. Molybdenum is required for sweetness in carrot and raffinose. It is the whiptail of cauliflower in is due to deficiency molybdenum. Then zinc. Zinc is a constituent of three enzymes, that is carbonic anhydrase, then alcoholic dehydrogenase and superoxide dismutase. It aids plants growth hormone and enzymes system. It influences translocation and transport of phosphorus. It is important for synthesis of tryptophan, a component of some proteins. It is necessary for chlorophyll production. It aids in seed formation. Then deficiency symptoms. It is first appear on younger leaves. In many plants, its deficiency produces a symptoms known as a rosette, in which the growth of main shoot is drastically reduced while the secondary shoot come up in large number. Then deficiency of zinc leads to first one is the Khaira disease of rice, then white bud of maize, then little leaf of cotton. Then this is the different stage of zinc deficiency. First picture shows that early stage of zinc deficiency, then second picture shows that progression of zinc deficiency, then third picture shows that the later stage of zinc deficiency. This is the chart of plant nutrients availability chart, that is the acidic range, neutral and alkaline, that is the pH range of the different elements. Then the table below list the essential elements and their uptake forms. Carbon contains CO3, then H2CO3, then hydrogen H plus and OH minus ions, then oxygen is the OH minus ions, then nitrogen is the NO3 minus, then also NH4 minus, then phosphorus is the HPO4 2 minus and H2PO4, then potassium is the K plus ions, then chlorine is the Cl2 minus, then calcium Ca2 plus, okay, then magnesium is the Mg2 plus, then sulfur is the SO4 2 minus, then boron is the H3BO3 H2BO minus BO3 minus, then magnesium is the Mn2 plus, then copper is the Cu2 plus, then zinc is the Zn2 plus, then molybdenum is the MoO4 raised to 2 minus, then iron content Fe2 and Fe3 plus, then nickel content. Okay, thank you.